Hi everyone, good morning, good afternoon, good evening, wherever you are. We are back again with our monthly meet for InfoSec Girls and InfoSec Diversity. And thank you so much, Claudel, for providing us this platform. Thank you. Um, Today's session is all about web application security basics, and we're going to be talking about how exactly web application is changing the space, and we'll also be covering OWASP top 10. So I will let Antara speak more about it. Antara, over to you.
Thank you so much, Vandana, for this lovely opportunity. Hello everyone. My name is Antara Mane. Just a short brief about myself. I am into information security domain for like past 3 years. Uh, working as a pen tester, somewhat into a compliance part, performing cloud audits and everything. Today's topic is web application security, why it is needed, and everything. We'll just cover it since once we move forward. So let's just get started. So the the talk about today's agenda is application security aspects, the need for application security, application security flaws, and last but not the least, OWASP top and vulnerabilities for 2021. So we are here today to understand why web application security is important. How difficult is it to secure web applications? What are the challenges faced by many organizations in implementing the security controls in any of the web application? So let's just go talk more about a first pointer, that is web, why application security is important. As we all know, the IT industry is like rapidly growing with the newer evolving technologies. So with these evolving technologies, we also have that has also led to many rise in many of the security vulnerabilities. There was a recent research done by Veracode, sorry. According to that research, 83% of the total 85,000 web application has major flaws in the application, and whereas the remaining 70% had at least one severe risk vulnerability is identified within their applications. So why rising this? So what's the main cause to rise in so many security vulnerabilities is because nowadays the web applications are easily available on the various network which are connected to the internet, right? Which actually gives access to some of the other controls to an arbitrary users, to identify certain security threats and vulnerabilities, right? So how an application security can help? So application security can help reveal those weakness in any of the web application, aiding to prevent from these evolving cyber threats and cyber attacks. So why do you need application security? So as we discussed, like, web applications are readily available on all the networks which are connected to the internet. So if you do not have appropriate security control mechanism in place, so an attacker would easily gain access to the resources, right? Majorly focusing on some of the other aspects of it, exploiting it to an extent that could actually lead to a reputational loss for any of the organization. So having application security in place it's like of a utmost importance if you are into the cybersecurity evolving field, right? So let's go talk about the application security problems that we face. So first one is there are many of the organization which actually lacks awareness on what application security is, the security controls and mechanism that needs to be in places. The process are not being defined appropriately, having complex architectural nature leads to several other vulnerabilities. Bad programming practices could also lead to severe vulnerabilities. Using of heavy payload encryption, having deployed it on a client side could lead to cryptographic flaws, some of the other budget concerns, and many more to it. So let's move on to the OWASP top 10. So what is OWASP top 10? OWASP top 10 is a OWASP is like short for Open Web Application Security Project. So it is an international non-profit organization dedicated mostly to improving the software security, software security controls through open source initiative and community guidelines, right? So it was founded back into 2001. The main goal of it is to help the website owners and the security experts to protect the web applications from the evolving cyber attacks, right? So OWASP publishes the details of each and every newer cyber security vulnerabilities that are identified in most of the applications, and the remediation strategy to mitigate those cyber attacks. So the very first version of OWASP was 2003, then it kept evolving, and the latest one is 2021. There are also several other initiatives that are undertaken by OWASP, like OWASP Mobile Cloud Pen Testing Project Guide, OWASP Software Assurance Maturity Model Development Guide, and etc. You can find more on the OWASP community website. So what's changed in top 10 for 2021? So there are there are certain aspects to which the webs has changed the ratings for some of the other vulnerabilities that are most commonly identified in many of the web applications. So the categorization of some vulnerabilities have been changed, the rankings of some of the other vulnerabilities have been changed, and now we have 2021, the latest vulnerabilities with the ranking, with the appropriate rankings of it, right? So let's dive into each and every vulnerabilities and try to understand how that what is that vulnerability and what causes that vulnerability and how to remediate those vulnerabilities. So these are the top 10 vulnerabilities for 2021. The first one is broken access control, second one is cryptographic failures, injection attacks, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, server-side request forgery, that is SSRF attacks. So let's understand each and every attack one by one, right? So first one is the broken access control. So broken access controls are the common, are very common in modern web applications, and the attackers regularly try to exploit them in order to compromise the user or gain access to the internal resources to which they are not authorized. So authentication and authorization flaws can actually lead to exposure of sensitive data or unintended code execution, right? So common access control vulnerabilities could actually lead to failure. uh, so if the application actually fails to enforce the least privilege access, so by bypassing the easiest access control checks or elevation to some of the privileged accounts, for example acting as an admin when actually it is being logged in as a user account. Failure to validate subject and object matrix. So subject and object matrix is basically used to identify the allowable actionables to that particular subject and objects, right? So there are three technologies for access metrics. So the first is read only, wherein the subject has only read only access to the particular object. Second one is append, where the subject has only write access but not to read the object. Third one is execute, where the subject is only where the subject has only access to execute that particular object, but it it neither has read or write access to it, right? So failure to follow a complete mediation strategy could also lead to a broken access control vulnerability. There are some common access control vulnerabilities that include force browsing, insecure direct object reference, part traversal, privilege escalation, and mass assignment, right? So let's just talk about a few. So forced browsing. So what is forced browsing? Forced browsing is a forceful browsing, which in which an attacker tries to brute force or enumerate and tries to access the resources that are not referenced by the application, but they can still be revealed by some of the other means, right? So for example, there are like two endpoints. Like first one is the user, another one is the admin. So what an attacker will do is attacker will try to forcefully browse the admin endpoint instead of being a user, and will try to gain access to the resources of the admin functionalities and perform further unauthorized actions to it. So this is what a forceful browsing is. Another one is part traversal. So part traversal is a web security vulnerability attack that actually allows an attacker to view files on the web server. So an attacker will, I mean, this is achieved by tricking either the web server or the web application onto which this particular application has access to some of the other internal resources. So for example, there is an endpoint to load an image with the parameter of file name, which actually loads a gif.png file. So here an attacker will leverage this particular utility to actually load the file, some of the internal file that actually that exists outside of the root folder. Since the web application makes use of this internal resources and actually has access to it, the attacker leverages utility to view the file, internal file, that it has not access to or should not be allowed to. So this is what the part traversal vulnerability is. Let's move on to the next vulnerability, that is a mass assignment vulnerability. So some of the other software frameworks actually allows the developers to bind some of the other HTTP parameters into a program, or code, a variable, or an object, which actually makes use easier to use that framework. But this actually causes harm in a way that an attacker is able to manipulate or modify some of the other objects, and tries to gain access to the resources that he or she is not supposed to access, right? So let's take an example here. So say for example, there is a form for editing a user's account information, right? So the form is like a basic form, like having a user ID, password, email, and submit button, right? So here the objects of that particular form is bind to the following parameter, that is string value is user ID, password, email, and is admin, right? So these are all the objects to it. So then here is the controller for handling the request, like add user method is like from post method, right? So let's understand the attack from an attack point of view, how this will work. So the typical request would be having user ID some value, password some value, email ID some value. So if an attacker was to exploit this, so what it will do is it will set value to the attribute is admin. So if the modification is done in the id admin para in admin is admin parameter, if it sets to true, that particular attacker can actually gain access to that particular account as an admin, right? So once the admin access is gained, so further it can also do some changes on behalf of as an admin, which is not authorized, or gain access to some of the other sensitive resources that it should not have access to. So this is what basically a mass assignment vulnerability is. And here are some real world examples for broken access control. Like there was one instance of no rate limit found on the forgot password page of a NordVPN that could actually able to bypass it. Uh, the reference link has also been mentioned in the PPT. GitHub lack of authentication, exploiting embedded submission form to bypass the authentication, insufficient access control on US DoD. These are some basic real world examples. So, how would you remediate broken access control in the real world? So, you should follow the rule, that is the rule of denied by default, right? To follow the complete mediation strategy, implement role based authorizations, not to follow presentation layer, because hiding resources obviously do not does not make it inaccessible. Always to have, if you have like a basic understanding of what an OSI layer model is, you could actually understand the presentation layer security. You don't want to go deep into it because we have a lot to cover. Next is very important to have, to always have two factor authentication in place, validating user access on the server side. It's another important factor to be followed. Okay, let's move on to the second type of vulnerability, that is cryptographic failures. So cryptographic failures are sometimes a root cause of sensitive data exposure, which can include passwords, credit card numbers, health records, and other personal information, right? So the most common mistake is when the encryption is not implemented appropriately, or the data is being transmitted in a clear text, or the weak cryptographic algorithms is being used within a web application, or you know the web application is not enforcing the secure protocol to transmit the sensitive data, right? Cryptography is very complicated. Obviously there are few many of the parameters to it, so let's not go deep into it. I'll just understand what actually cryptographic failures is. So let's understand what first encryption is. So encryption is basically converting a plain text into a ciphertext, which an attacker of any arbitrary user cannot cannot understand it, or which is not really understandable, right? So except for the authorized parties which have the keys and can decrypt those particular ciphertext, can understand what that message is, right? So encryption are of three types. It's symmetric, asymmetric, and hashing. Symmetric is a kind of an encryption in which same shared key is used to encrypt the plain text into a ciphertext, and the same key is used to decipher the ciphertext into a plain text at the receiver end, right? The algorithms for symmetric are AES, DES, 3DS, etc., so on. For asymmetric one, a public key is used to encrypt the data at the sender end, and a private key is used to decrypt the same ciphertext data at the receiver's end. And hashing is like a one way function. If a plain text is converted into a ciphertext using some using some hashing algorithms, so there is no way that you can actually reverse it, you could actually decrypt it or something. And hence hashing is sometimes considered as a more secured encryption type in comparison to symmetric and asymmetric ones, right? So let's understand what are the common crypto mistakes. So first one, we talked about this. So using weak algorithms, using weak ciphers, making use of weak or default encryption key, using pre-shared keys, using improper key storage, using improper key rotation. It's a difficult part of the cryptography. Not using a random IV with CBC mode. So what is a random IV? IV is an initialization vector, right? That is basically used for encryption, for data encryption. So it is a random value that is used for data encryption. So so initialization vector, it is basically used, uh, so basically when an encryption happens, uh, it actually avoids multiple encryption with the same algorithm, with the same key. And when it actually encrypted multiple times, so it ensures that the resultant of that particular encrypted value is not always the same. So how it works is, so the initialization vector, so value of it is added to the plain text, or to the plain text of a to the block of a plain text before encryption. The resultant of this particular ciphertext is added to the next block of the plain text before the encryption, and so on. So this is how the encryption with IV with CBC mode is happened, just adding an additional layer of security. So if a random value of IV is not used, that can actually create a problem here with cryptography. Sensitive data transmitted over an HTTP channel, hard coding the key in the binary, sensitive data stored in the plain text, payload encryption at client side. I have a very good example of this. I'll cover in the next slide. Using homegrown cryptography algorithm, some of the basic cryptography flaws. So let's understand this payload encryption example. So this was actually identified in one of my pen tests. So it was an insurance application basically, and it was, if you would see in the first POC here, so it is actually it is actually sending some encrypted value, and at the response that it is, you are actually getting some encrypted value. If and at this so after viewing the source code of it, the view source of it, using the developers tool, I identified that there was salt value which was hard coded. There was crypto logic that was disclosed, and obviously the salt IV value was also disclosed. So with the help of that crypto logic, I actually created a HTML file that will basically just decrypt and encrypt the payloads, right? So the data that the particular application was sending, so I decrypted that value using the the salt and hash key that was available at the client side, that was actually hard coded at the client side. So after decrypting and identified, it was passing some of the other SQL query in it, right? The rest of the value is hidden due to security reasons. So I identified it was passing some SQL value, a SQL query in it. So I modified the SQL value to actually extract the customer data, which actually included Aadhaar card numbers, the mobile numbers, address, and many like bunch of security sensitive data. So this is one of the example of payload encryption at client side. the impact of it, right? Let's move on to the next. So how would you remediate this attack? Know your regulation, do not store data if it is not required. Always best practice of storing the key, password and data separately, not within the binary code. You For hashing, use SHA-256 with a good random salt value. Discontinue the use of SHA-1 and MD5 algorithm because they are deprecated ones. For symmetric encryption, it is always recommended to use AES or 3DS algorithm because they are considered as more secured ones. Use secret managers or vault to store the encryption keys. This is the challenging part for many organizations, how to securely store and manage the API keys and encryption keys. So using secret manager or vault, Azure Vault, or maybe any other thing. That's a recommended word that you could actually use to store your encrypted data keys. So here are some real-world examples of cryptography failures. So a weak cryptography and password reset lead to a full account takeover, right? Uh, Ablovin API key was hard-coded. So what happens if you use a hard-coded API keys in your binary code? So if at all, if an attacker identifies this particular instance where the API key is hard-coded, and if the application is if the I mean obviously the attacker will monitor what all API calls being made within that web application. And if it found an instance where an API is using, there is an API call made that has some that has some encrypted value, and the response to it some encrypted value. So the API key will actually will be utilized by the attacker to decrypt that encrypted data. So it is not recommended to hard code any API key within the binary code, right? So let's move on to the next part, that is injection attacks. So what is an injection attack? So injection attack, it refers to a broad cast of vulnerabilities. The reason I'm saying because that allows an attacker to supply hostile or untrusted data to an application via an input form, right? Basically tricking the code, into executing unintended commands, or accessing data without proper authorization. Uh, the most common injection attacks are SQL injection, NoSQL injection, OS command, expression language, cross-site scripting, XML entity attack, server-side injection attack. So let's understand what SQL injection is, right? So SQL injection involves placing SQL statements in a user supplied input, basically trying to gain access to that particular DB, querying the DB to gain access to the tables, columns information, stored username and password information. So I have a good example of it here in the image that says drop database, and that particular ties in place. So we all know that this basically um, the typical speed camera that traps have this built-in OCR software that is used to recognize a license plate, right? So what an attacker did is, so attacker it basically created a simple SQL statement to hopefully cause the database to delete any record of that particular license plate, right? So and one good reason that this should or could have worked is because while we only think that a traffic camera is only taught to recognize the license plate characters, right? While the developers of the third party image recognition software simply digitize the entire thing, recognizing any and all sort of characters present, right? So this is still uncertain that whether this particular attempt that was made, is it successful or not. But anyway, I found it like a good example to discuss today, so I've put it there. So let's move on to the next part, that is the remediation part. How would you remediate injection attacks? So first one is to have input validation in place. Whitelisting is all time preferable, you know, preferable, considering to blacklisting, because we have variations of SQL payloads, and blacklisting is sometimes not enough to completely cure SQL injection. Using regex based validations a must one. Using parameterized SQL queries. So the parameterized SQL queries, so it basically is a prepares statement that helps avoid the attacker to modify the SQL query in which it is not intended to perform actions to, right? So, for example, if an attacker tries to bypass an authentication using a simple Boolean-based SQL queries, So parameterized queries will actually treat that entire boolean based sql query payload as a string, and it will actually try to match that pattern, right? If the pattern is not matched, right, so it will simply throw an error. It will not so it will not actually try to execute that boolean based sql query. It will actually treat that as a string value and try to just match the pattern of it. So parameterized sql queries are considered the best recommended uh, you know remediation to cure SQL injection. Uh, Following the principle of least privilege, when SQL injection is actually successfully exploited to that extent where an attacker gains unauthorized access to the DB. So it is. I mean, I have usually found that discovered that most of the DBs are running with the high privilege, that is the root user privilege account. By having root privilege, you could actually modify and delete some of the other tables or columns, dump all the username and passwords. So it is always recommended to follow the principle of least privilege, like make, like, do not allow a complete high privilege access on any of the databases, right? Let's move on to the next one, that is an XML external entity, also known as XXE attack. So XXE basically it is a web security vulnerability that allows an attacker to interfere with an application's processing of XML data, right? It often allows an attacker to view files on the application server file system, and to interact with the backend or external system that the application has itself has an access to, right? So it basically attacks if the if the XML parser is weakly configured. XXE can also lead to information disclosure, accessing, like viewing file internal files in a way that any arbitrary user should not have access to, right? Server side request forgery, denial of service attacks, just creating payloads of it, right? So an example is disclosing the etc file or other targeted file. So how basically this this payload works. So to perform an XXC attack that actually retrieves an arbitrary files from the servers, you need to actually modify the XML content in such a way. Either you can edit the doc type element that defines an external entity containing the part to the file. That's what this payload talks about. And edit the data value in the XML that is returned in the application's response to actually make use of the defined XML entity, that is the last one, making a function of it. So having these sort of modifications, you can actually view the maybe any arbitrary files on the server that is running on the server. So let's understand how the XXC attack flow works, right? So let's take an example of let's take a bookstore theme example that consists you know that consists of form like a simple PHP web application that is hosted on the server, and it is intended to accept the book input from the user containing containing the information such as author title, the publishing date, etc., right? So this information can be sent through a post command, right, to the website. So here what happens is, here the attacker can actually utilize the XML entities defined, right, and the system identifier on the XML parser in order to retrieve the arbitrary files from the server, right? And the the reason the firewall will not block this request is because the functionality of these services are not directly being attacked. The attacker is making use of the XML entities, right? The system identifier, and in that it is creating its payload, its malicious content, and then trying to retrieve the files from that backend server. Using the utility of LFI, an attacker is simply draft the payload, cause the server to disclose the arbitrary file that the attacker is intended to view. So this is how the XXC attack flow actually works. Um, how to remediate XXC is to validate the XML files, ensure that the external entities are not allowed to, within the file parser. The modifications to the external entity should be blocked, prohibited DTT processing, document type definition, which actually contains the information of the structure and the attributes of an XML files, right? So that should be blocked. There are further readings to it. Obviously, you can just, if you want to understand it in a more efficient way, you can refer to the reference link. So yeah, so here are the few real world examples of injection attacks: a blind sequelae on Zomato, code execution on USDOD, XXC on Informatica, LFI to command injection. A few real world examples. So let's move on to our next slide, that is insecure designs. So insecure designs mainly focuses on the risks related to the design and architectural flaws, right? Um, and represent a broad category of it of the design weaknesses, the architectural design weaknesses, right? So to study the secure design principles and patterns, there are a few which are already in which are already being defined by OAPS. Few are listed below: security development life cycle, threat modeling, software assurance model. So here is a pretty good example of what insecure design architectural principles could lead to. So say for example, if you have an insecure parametric cookies used in the session management, and if an xx attack is successfully executed on that particular web application, so in that xxc an attacker could actually extract the cookies, right? The the session management cookies of it. And by having by having extracted these cookies, the attacker can actually make a login attempt without actually having the credentials within. So it can make it's like an fully account takeover of that particular victim, right? So having this design flaws, it could lead to a chain attack and further focused attacks, right? So how would you remediate this? So you should establish a secure development life cycle, a secure design security, and established, and make use of library that is that follows the secure design patterns. Make use of threat modeling for critical authentication, access control, business logic, and keys flaws. Also limiting the resource consumption by user or any service using any of the web application. Some of the real world examples for insecure design is the cache poisoning due to insecure design, clear text password storage, design flaw leads to multiple gift card redemption, insecure design implementation on MFA. Some real world examples. So let's go ahead and talk about security misconfiguration. So here you would see there is an image that has multiple lock patterns to it. Uh, the basic flaw this image contains is all these lock patterns are on the inside of the door and not on the outside of the door, right? So this is exactly what a security misconfiguration in a web application is. So security misconfiguration vulnerabilities occurs when web application components are configured insecurely or incorrectly, that basically exposes some of the other features directly to any arbitrary users, that is considered confidential, right? So this can happen at the level of application stack, including network services, web servers, application servers, and DBs. So this leads because hardening is not in place. Some of the other security features are not configured properly. Sensitive configuration, like we talked about the web server that are configured weakly, right? The product version or this is exposed via via the error method, right? Error message usually discloses the version and product information used at the backend. Using products, end of life products in use, right? So let's take an so here is some of the other example of information disclosure through error message, disclosing the decryption key, disclosing the runtime framework used in the backend, right? Another example is disclosing uh, the web directories via robot.txt file. uh, Not removing the hard coded HTML content. If you would see here, it is using a hard coded DB admin credentials, right? And the developer unfortunately forgot just to remove this it is also written there, remove the following comment during production movement. But due to some of the other reasons, it might have just got forgotten, or maybe something other reasons, and this could actually lead to further attacks, right? So the remediation would be to not disclose information from all the sources like HTML comments, robot.txt files, or error message, right? Or to always use generic error messages whenever you are attempt to throw an 404 error or any error message, right? Keep the software versions up to date, maintain all the security patches are applied uniformly, change the default username and password if it is being used in by some of the other means, right? Real world examples for security misconfiguration: Shopify 2FA misconfiguration, reset password feature misconfigured, GitHub auth misconfigured on record sensitive information disclosure. Let's move on to the next vulnerability, that is vulnerable and outdated components. So most application relies on a lot of third party code, right? Libraries, uh, which developers sometimes do not have the knowledge from the source which they are downloading it and using in their applications, right? So this particular vulnerability mainly occurs um, when a software or any component that it is using is unsupported or out of date, or is vulnerable to some of the other known cyber attack, right? So developer nowadays, they are heavily rely on the third party libraries to for certain uses in their web application, maybe the styling of it, the maybe dynamic linkings of it, something like that. But they're not aware of the source or the integrity of that library that they are using, and that actually leads to this type of attack, right? Commonly vulnerabilities are of the known third party components exploited are to RCE, remote code execution, local file inclusion, privilege escalation, authentication bypass, and SSRF, right? And here are the top most exploited vulnerabilities from 2022 with the use of the vulnerable and outdated components, right? So it has led to a drastic impact on many of the organizations which were using the known and vulnerable components, right? Let's move ahead with the remediation. So you need to keep a track of the third party components that are being used by your application, the source of it, the integrity of it. Check regularly if there are any newer versions related to the third party components that you're using. Update your vulnerable component as soon as possible. Uh, so these are the few remediation that you need to follow. Real world examples for vulnerability and outdated components are unauthenticated file read in Cisco ASA, unauthenticated stored cross-site scripting in BBPress, Jira accesses, unauthenticated arbitrary deletion Cisco, file deletion Cisco. So let's move ahead and understand the next type of uh, vulnerability, that is identification and authentication failures, right? So this occurs when the functions related to the user's identity or authentication or session management are not implemented correctly or adequately not protected, allowing an attacker to gain access and assume the identity of the user, right? So an application is vulnerable to identification and authentication related attacks when a weak mechanism for a forget password or recovery in use, which is easily guessable in, and one can actually try brute force attack also to actually understand the pattern of it, right? Social media site leaks username and passwords that can that's actually GitLab. These are actually mainly examples which actually leaks username and passwords, or the developer unknowingly or unintentionally exposes this sort of information. Standard guessable username and password, which can be brute force using a dictionary attack, right? Passwords are stored in a clear text in the database. If a exploit like SQL injection is exploited, so one attacker can easily gain access to the username and password because they are stored in a clear text manner, right? So what are the basic authentication bypass techniques? SQL Boolean code, Boolean payloads, Boolean based SQL injection, brute force dictionary attack, weak or predictable session IDs, right? So, what are password related issues? So password reset link sent to the registered email address. What if the password email reset link, the parameter of it, the email address parameter is is like manipulated, and the application is not able to actually block that particular manipulations, right? So if the password link was supposed to send to the registered email address ABC, and if I am manipulating, if an attacker is manipulating the email address parameter, and the same password link is being sent to the attacker's Gmail address, so it can easily take over the victim's account, right? The email contains the following reset link. If you would see, there is a parameter here that contains some random value, right? So how random is this? Is it guessable one? So you could actually modify it and can perform further focused attacks. So can this link be used again? Is this link reusable, right? Is there any expiry time for that reset link, right? So these are the common password reset issues that were identified in many of the web applications. The examples to it is so this was actually from the pen test, from my pen test. So uh so one of the application was having PHP myadmin running with the root privileges, right? Exposed on the internet. Basically this should be restricted within your uh sorry this should be restricted within your local host only, but it was exposed to internet, with the root privileges. Another one was the directory listing, the index of uploads, where it contained a web shell, which further lead to a remote code execution attack, right? So these needs to be taken care. So how would you remediate this kind of an vulnerability? Is to implement strong forget password mechanism, avoid using standard passwords, limit the failed login attempts, right? Use server-side built-in session identifier to maintain and secure the authentication and authorization process. These are a few real-world examples for identification authentication failures. Unauthenticated access to MongoDB, uh, exposed due to default credentials. Exposed Prometheus instance, directory listing on OLX by passing 2FA using OpenID misconfigurations, right? So let's move on to the next one, that is software and data integrity failures. So this is something that relate to the code and the infrastructure that do not protect against the integrity violations, right? So when you use some sort of third party software plugins or libraries or modules from untrusted source or repositories, right? And maybe content delivery network, that is CDNs, and they can actually introduce you to a potential unauthorized access, or modification of that to a malicious code, or compromising the system, right? So this basically mainly occurs due to the dependency. The application dependency relies on the third party libraries, models, or plugins from an untrustworthy source, right? The developers also fail to identify the integrity of it, which leads to the data integrity failures. So here is an example of software and data integrity failure. So say for example, this is also called as dependency confusion attack. This is when an developer do not verify the source and integrity to what package or what library they are installing, right? So this is just a small research that I did. So I created this package called as I created this package called as my internal package. There I had a URL to uh, endpoint which has a malicious code. And basically when you install my package, this package, so it actually runs some of the other CMD commands unknowingly, like so it is just blindly using blindly just downloading packages from an untrusted source, right? Not verifying the integrity of it, and even verifying the source to from where you're downloading, right? So yeah, you can find this on the GitHub link that I've provided. So this is what happens when you actually download that malicious package instead of the non-vulnerable one. Okay, let's move on to the next one, that is serialization and deserialization attack. So what is serialization? So serialization, it is a process of converting a complex data structure such as objects and the fields uh, into a format that can be sent and received as in sequential streams of bytes. By writing this complex data to enter process a memory or a file or a database. So sending a complex data, for example, over a network between different components of an application or in an API call, right? Crucially, when serializing an object, its state, it is also a persisted ones. So in other means, the object's attributes are preserved along with their assigned values. And deserialization is a process of restoring the same objects, the bytes of stream to a fully functional replica of an original object. uh, so what happens is, uh, insecure deserialization attack. So insecure deserialization occurs when an attacker is able to control the data that is being serialized by any web application. So this potentially enables an attacker to manipulate the serialized object to pass malicious data into an application code, right? Maybe intentionally to view some or the other, or gain access, unauthorized access to some of the other internal file that are being running on the server, or something like that, right? Real world examples for software and data integrity failures are deserialization to RC, right? One can convert deserialization to remote code execution. Inclusion of malicious code, able to when the object is like an attacker controllable object, right? Downloading code without the integrity check, right? Deserialization of Jackson libraries. This is some of the examples of it. So let's move on to the next slide that talks about security logging and monitoring failures, right? So these are basically the bedrock of nearly every major incident, right? Attackers rely on insufficient logging and monitoring and the slow response to gain to the foothold into your application and actually achieve their objectives while remaining undetected. On an average, it takes like you know 278 days, like for any in general company, to detect and contain a new breach, giving the attackers plenty of time to cause the disruption and damage, and cause reputational loss for any organization. So this occurs if your application is not able to maintain the auditable events, such as such as login, failed login attempts, high value transactions, the warnings and error messages generated, inadequate or unclear log messages are generated, logs of application and API that are not monitored for suspicious activity. Logs are only stored locally, which would also lead into another type of problem. Appropriate alerting thresholds and response escalation process are not in place or effectively managed by organizations. Application cannot detect or escalate or alert for active attacks in a real time or near in a real time. So these what causes uh, this was actually gives a utility for an attacker to carry on to the further focused attacks, right? The remediation would be obviously to have an active monitoring and alerting mechanism in place, security controls in place for detecting suspicious activity, having an active response team uh, for, for these particular activities, ensuring log that is appropriate log data is encoded correctly to prevent from further unauthorized access, ensuring all the crucial activities are logged, establishing or adopting an incident response and management system and security control in place. So these are some of the other real world examples of security logging and monitoring. um, So it is Brave browser misconfigured logs, HTMLI via log view, debugs logs exposed publicly, right? So let's move on to the last vulnerability, that is server side request forgery. So server side request forgery, basically it is a flaw that occurs when a web application does not validate the user supplied URL when fetching a remote source. So this allows an attacker to, forcefully to force the application to send a crafted request to an unexpected destination, even when the application is protected behind a firewall or VPN or any type of, access control list, right? So SSRF flaw can, uh, occur when an application is fetching a remote source, without validating the appropriate user supplied input. SSRF can also allow an attacker to access arbitrary files from the server, by querying the internal network. Let's just, understand how this could happen. So here is an attacker. We have a firewall in between. There's a victim's vulnerable system, and that server is communicating within another internal networks, right? So if an attacker is sending an HTTP request to server C, the firewall can, readily block it can easily block that request due to uh, due to the policies that have been configured, right? So, in order to successfully execute SSRF attack, what an attacker will do, it will create an legitimate HTTP request with an SSRF payload to make an out-of-band call to a victim's vulnerable server, right? So, this will be passed to the server A, right? The server, because it is a legitimate request, right? So, the firewall will not look into the anomalies of it. So that particular request will be received by the vulnerable server A, which will serve and process the request. Based on the SSRF payload, it will trigger the malicious request to query the internal resources, that is maybe C. uh, so the request can go like from C to D, D to B, B to C, the way the payload has been configured. And using this, this mechanism, an attacker can successfully, communicate to the internal resources, that is B, C, and D, which are restricted when communicated directly, uh, dire- when querying directly to any of this server, right? So this is how, an SSRF actually works. The remediation for to mitigate SSRF risk from application side of layer, from application layer, is to sanitize and validate all client side, all client supplied input data, enforcing the URL schema, port and destination with a positive allowable, because SSRF is basically you're querying the internal resources, maybe to, identify what all services are running internally, uh, you know knowing what all, services are up and running, what all ports have been exposed, and something like that. So, you should have, a URL schema or port or destination validation with a positive allow, like whitelisting this critical or crucial parameters, right? Do not send raw responses to the client, right? Disable direct HTTP redirections, right? From a network layer, it is, it is always good to have an, deny by default firewall policies in place, right? Network access control rules to block all but the essential intranet traffic, right? So these are the remediation step which you could actually, have into your, while configuring your web server from either application layer and on the network layer. So these are some of the real world examples to which was, vulnerable to SSRF. So SSRF was found in a PDF rendering using an, SVG payload, SSRF on USDOD, SSRF via file upload, change SSRF to an a remote code execution attacks. So this was all for today's session. I hope you have, learned at least the basics of security, web application security vulnerabilities, and thank you for joining for today's sessions. Over to you, Vandana.
Yeah, thank you so much, Antara. I think that was really amazing. And we will be sharing the deck with everyone. If anyone has any
Yes.
questions, probably we can reach out to Antara. Antara, can you share your Twitter handle or LinkedIn ID?
Sure, sure. Just a
Yeah,
moment.
please.
It's in the chat box. I've shared it in the chat box.
Yeah, I've posted in the chat box. So if anyone wants to connect with Antara, you can reach out to her on her LinkedIn. Yeah, thank you so much, everyone, for joining us. It was a good session, amazing session.
Thank you so
Thank
much
you.
for this lovely opportunity. Thank you.